In this video, I'm going to be talking about inverse functions. Inverse functions have the following characteristics. They are all listed out here, so if you want to take a second, pause the video, write them down, go for it. Probably is a good idea. Inverse functions are f to the negative 1 of x. This is not take the negative 1 exponent of it. It's just the notation. Just literally just means that this is the inverse function. Just like we know a function is f of x, f to the negative 1 of x is just f inverse of x. So we just say that this is f inverse of x. They pass the horizontal line test. Okay, if we're looking at our original function, say these two pictures over here. This is my original function, the square root function. And I want to know if the inverse of this function is a function. So in order to do that, I run a horizontal line test just like I had the vertical line test. But as long as it doesn't ever touch more than 1 point on my horizontal line, then I know the inverse is a function as well. Okay, looking at the graph y equals x squared, notice that if I run a horizontal line test, it hits more than 1 point pretty much all the time. So this one does not have an inverse function. Okay, also, f inverse of f of x, this is function composition, is equal to x, just like f of f inverse of x is equal to x. This is how we test these things algebraically. We kind of do the composition on this side, do the composition on this side. As long as they both come down to x, then this thing works out. We have an inverse function. If you want to prove this thing graphically, here's my original function over here. They are reflected over the line y equals x. So I always draw this dotted line, y equals x, and I can see here's my function. When I take the inverse, I will find out what it is. I'll have f inverse of x equals whatever it is. Okay, and I can draw it, and I can just visually see that this is a reflection over the line y equals x. I can fold it in half over this line, and it will line up with itself. I'm going to do a couple of examples where we're going to have to find and prove the inverse that it is an inverse function. So first step, we have this function, f of x equals square root of x plus 7. You can also consider that this is y equals the square root of x plus 7, since in order to find the inverse, all we do is switch places with the x and y. So in finding the inverse, when I change places, x equals the square root of y plus 7, and then I just need to solve for y. Well, first step in doing that is to square both sides, so that I have x squared equals y plus 7, and subtract 7. So I know y equals x squared minus 7. Now here's the thing you got to be careful with. We have to use our correct notation. So I actually have to say, instead of y, that this is f inverse of x equals x squared minus 7. It is not correct unless you have this f inverse, because this tells us that it is related to our original function and that it is actually the inverse function of this thing. Now in order to prove this thing algebraically, we need to take f inverse of f of x as well as f of f inverse of x. Okay, we need to prove both ways, that they both come down to x in the end. Well, on my left hand side, I have f of x on the inside, so I have f inverse of whatever f of x is, and f of x is the square root of x plus 7, so square root x plus 7. And then this says go to f inverse, plug in square root of x plus 7 where there's an x. So I'm going to go to my f of inverse function, and I'm going to plug in square root x plus 7 where I see x. So x plus 7 squared minus 7. Well, when I square a square root, that just kind of makes it go away. So x plus 7 minus 7. 7 minus 7 is 0, so I'm left with x. That side's good. Then you have to do the same thing to this right hand side. This says f of f inverse, and I know my f inverse function is x squared minus 7, so I can put in x squared minus 7. Now go to f, plug in x squared minus 7. So I'm going to go to my f, plug in x squared minus 7, so this is the square root of x squared minus 7. I replace that for x plus 7. Now I have that negative 7 plus 7 is 0, and I have the square root of x squared. Well, the square root of x squared is x, so That side checks out as well. Therefore, my inverse of this function is a function as well. Alright, doing the same thing, going to find the inverse and prove it. This time I'm also going to do it graphically as well. So I know this function is y equals 5 minus 7x. Okay, it just makes it easier than saying f of x so that I can just switch places a little bit easier. So now I have x equals 5 minus 7y to find the inverse, and I'm going to solve for y. So I have minus 5 on both sides equals negative 7y. Divide by negative 7, so y is x minus 5 over negative 7. Don't forget to rewrite this as f inverse, so f inverse of x equals x minus 5 over negative 7. So I have my original function, I have my inverse. I'm going to use both these things to prove it graphically as well as analytically, or algebraically. So I'm going to do the algebraically first just because it's a little bit more fun, because you guys love this. This is awesome. It's the best thing ever. Okay, f inverse of f of x. I know what f of x is, so I'm going to put in f of x into my equation. So f of inverse of 5 minus 7x. Then I'm going to take this 5 minus 7x, plug it into f inverse, so go to f inverse, plug in 5 minus 7x, where you see x, so 5 minus 7x minus 5 over negative 7. 5 minus 5 is 0. Then I'm left with negative 7x over negative 7, which is 1. So I'm left with x on that side. We are good to go there. Then I have to do f of f inverse of x. Okay, f inverse of x is x minus 5 over negative 7, so f of x minus 5 over negative 7. Then I'm going to go to f, plug in x minus 5 over negative 7, where I see x. So 5 minus 7 times x minus 5 over negative 7. And then I have negative 7 times negative 7 is 1, so I have 5 plus x minus 5. 5 minus 5 is 0, so once again I'm left with x, so that checks out. Now for the graphing. This stuff has to reflect over the line y equals x. So I'm just going to go ahead and draw my line. Y equals x, just kind of make it easier. Yeah, dashed lines. Okay, again, my graphing is going to be really hard, or bad, because it's very hard to graph, but I'll do my best. So if I want to graph my original function, I'm going to do it in black. 5 minus 7x. I know I'm going to cross my y-axis at 5, 3, 4, 5. So I can put a dot there. Now I go down 7 over 1, because I'm using my slope. So down 7 over 1. Okay, and let's see if I can make this straight line. Ooh. Yeah, it's kind of close. Kind of close. Oh yeah, that's a beautiful straight line. Alright, and then the other one, x minus 5 over negative 7. If you want to, you can rewrite this to kind of help yourselves out. This is x over negative 7 plus 5 over 7. So I know I'm going to cross the y-axis at 5/7, so it's somewhere in there. I'm going to go down 1 over 7, so down 1 over, let's make my little tick marks. 1, 2, 3, 4, 5, 6, 7, how about? So I went down 1 over 7, and I'm going to kind of draw a straight line there. Okay, if they were better straight lines, these things would cross right here, and you can kind of see it. I wonder if I have a tool on here. I think I do. I can make a line. There we go. So how about, oh, but it's not straight. Okay, but they kind of come close to crossing. They're supposed to cross at the line y equals x, because that's what it's reflected over. Hopefully this video helps you guys out. If you ask me questions, I will see you all in class tomorrow. Have a good night.